there. So let's, real quick, I want to turn my machine on up front here. And again, I am not forcing anybody at all to use a TIDE3. I simply made that little document for those of you who have a TIDE3. Let's put this right here. And it looks like most of you do. But I shouldn't say most, but a good chunk of you do, maybe most. You can do this mathematics in Excel. You can do this mathematics probably online via web pages and things like that. Okay, there's plenty of other places besides the 83, but in class, since a lot of you have that, it's just a nice thing to have. If you want to use an app, a downloadable app to do this, totally fine. Some of them are free probably. So the mathematics is not hard, it's just tedious. And as long as somebody codes it into some kind of software, you're good to go.
Can I ask you a question?
Yeah, Mike, go ahead.
Taking a little step back almost.
Yeah.
The number 1.05.
Yes.
I thought we came up with a different number.
We did. Hold that thought.
Okay.
Can I postpone your answer for 3 minutes?
Sure.
Mike's got a great question. We had a different number for slope. We had 1.125. We have 1.05. Let's come back to that if you don't mind. If you don't mind. All right. Let me. I got other data I got to get into here. Hang on. Okay. So 2, 4, 6, 8, 10. Yeah. Could you guys throw out the other data? Your L2 data?
35, 38.
35, 38?
39, 41, 44.
Thank you so much. Fantastic. So we got this. First thing was to make a scatter plot. Now what's nice about setting your scatter plot up the first time, as long as you keep putting your data in L1 and L2, it'll just keep drawing scatter plots on that data. It's pretty slick. Keep the booklet around though. That's in case you forget something. That's why I gave it to you in a booklet form. Golden, already turned on. Oops, wrong equation now. Let me turn that off. Zoom 9. Boom! Looks like yours, yeah? Yep, pretty good, pretty good, pretty good. Awesome. So now your line, this was the part that was a little bit, you guys actually had, it sounded like you had better success than most classes. I'm stoked. I think I keep tweaking the booklet to make it simpler and hopefully more understandable. And when fewer people have problems, it makes me happy. Some things are just technological we have to fix because there's something missing. But stat, calc, linreg, y-vars, boom. The key, some of you are asking me why we have to put this here, and the answer is you don't. You don't have to put that there. But when you put it there at the end and you press enter, it tells you that your slope is 1.05 and your y-intercept is 33.1. Mike, first question I want to answer Mike's, we got a slope of 1.125 when we were doing it by hand, yeah? Why? Why is ours, better question, why is ours different than this one? Another question, what was our slope based off of? How did we get our slope?
Average.
We averaged the known points in the data set. In other words, we assumed that the data points that we had to be used directly, 2 of them, the first and last, in the calculation. That is not necessarily true. It's not necessarily true because if you do that, remember the residual squares that were popped up I drew on the board, those residual squares? If you use actual data points, you might create residual squares that are bigger than if you don't use the data points. Now, believe it or not, and you can say I don't believe this, you're full of crap rule, this is measuring those squares. You see these big sum, these big sigma things right here? Now, if you've never seen that before, that's the Greek letter capital S, sigma. That Greek letter capital S sigma means add. So what this computation is actually doing is summing up all of those residual errors. It looks kind of weird because you see things like x times y and x, and you see x bars and y bars. It's all statistical lingo. But that's what it's doing. You would do it geometrically, and this is what this video that I keep referencing, the video I made actually explains geometrically, not statistically. And it shows me moving a line and watching the squares grow and shrink. So basically, Mike, the reason ours was different than this is because ours was based on the wrong 2 points. The better 2 points are hidden inside of this. Is that a fair answer? If you want a better answer, the video is posted off the homework page. If you want an even better answer, there's an explanation I've written out using calculus that explains where these formulas come from. So it depends on A, how much of an answer you want, and B, how much coffee you're willing to drink to understand it. There's other YouTube videos out there too. But this YouTube video has actually gotten a couple tens of thousands of hits. People actually like the explanation because it does kind of make sense. Somebody explained it to me years ago like that, and I'm like, oh my god, that makes perfect sense. The world needs to see this. And this was back in the day when you didn't have fancy YouTube crap. So I decided to make a YouTube video that had it all in there so you could understand. But just to understand why, this is the best possible slope for those 5 points, 1.05. Fair enough? Now the reason why the y1 is there is because now, if you press the y equals button, your equation is actually living in y1. So when you press the graph button, the line will show up with the data. So I'm not sure how many of you used that vars button in Math 95. I'm guessing about less than half of you or fewer than half of you use that vars button. We'll use it a lot in this class because it's a very handy way of dumping the equation. Otherwise, you have to type it in, which is kind of annoying. You have to type the equation in. So, is this recording? Yeah. It is good. Now, first question, it goes back to Mike's question. The slope of this best fit line is 1.05. Yes, it's 1.05. Correct. What does that mean? What does it mean when I say in context? Use the units of the data. What does it mean in context of the data?
It's only 0.05.
1.05. What does it mean? With respect to the data, what does it mean?
It's an average.
It is an average. You can use the word average, a different kind of average than the one we did. But on average,
Number of people goes up that amount per year.
love that. Say, can you name it again one more time?
Aaron.
Erin, did you hear what Erin said? She was very quiet, so I want to amplify it for you. She said the number of uninsured people goes up that much per year. Can I add 2 words? That many of millions. Because it's 1.05 million per year. And I'm going to add 2 more words that are not necessary but might make sense. On average. On average, the increase per year in the number of unemployed is about 1.05 million.
Uninsured.
Uninsured, right. The increase in uninsured is about 1.05 million per year. Now some of you are going to say, wait a minute, time out. It was like 3 and 2 and 1 and 3. Remember those slopes we were looking at before? But that was every 2 years, right? 3 over 2, 1 over 2. 3 over 2 is 1.5 over 1. 2 over 2 is 1 over 1. So actually, this is darn close to the average of 1.125 that we got. But this is the best possible fitting slope for the model. You see what I'm getting at there? Is that fair? So that's what the 1.05 means. The 1.05 means on average, we are going to pick up each year about 1.05 million uninsured people. If the trend continues, go Kelly, please.
Why is it using the 33.1?
That's a fantastic question. It has to do with this piece right here. It has to do with the piece at the end there. It's the best fit to minimize those squares. So it goes back, Kelly, if you don't mind. Did I erase it? Oh crap, I erased it. Remember when I had the extra lines drawn on the board and then I had those squares drawn? Even if you have the right slope, if you drop the line or rise the line too much, now that would be a function of the y-intercept, wouldn't it? Because once you, think about it, once you fix the slope or the tilt of the line, once you've tilted the line correctly, you then have to decide how up or down it is to be positioned correctly. If you make it go too high or too low, those squares are going to get bigger or smaller depending on where they are. The 33.1 situates it so that the squares are as small as possible. And I hate to offload this to that video again, but in that 7-minute video I explained that too. It's all in there. It's a function of moving the lines around.
Well, it made sense.
No, and it's a fantastic question. I want to make sure it gets answered. I don't harp too much on what the 33.1 means, but let me ask one time, what does the 33.1 mean?
Where's the y-intercept?
It is the y, yes, tell me that again, Justine. Justine, it is the y-intercept. So what would that mean technically?
It's the number of people uninsured in year 2000.
In the year 1990, right? 1990?
Oh,
In
yeah.
the year 1990, we would predict 33.1 million uninsured people based on this model. I don't harp on that too much because depending on where you decide 0 is, that number could be wildly unusable. Like for example, we made 0 be 1990. Suppose you made 0 be the birth of Christ, as in year 0, or year 1, whatever, right? Then you're out 1,990 points, and your y-intercept is going to be negative some ridiculous thing. And then it becomes useless. So I harp more on the slope than the y-intercept, because the slope actually is important. The slope is what the news talks about when it says the rate of uninsured or the rate of unemployed or blah, 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 blah. They're talking about the slopes of these curves, not the intercepts. Because the intercepts, as you may have learned in Math 95, you can raise them and lower them all day long to put them somewhere more convenient. Does that make sense? Any questions you guys have right now? Because I think we're going to call it a day. I want to get to these questions, but I don't want to get to these questions in 3 minutes. I think it was more important to get the stuff into machines, yes, get them in the machine. So here's the deal. I don't see you guys again until Wednesday, right? Because I think we have a holiday Monday, don't we?
Yeah.
It's Martin Luther King Day. Martin Luther King Day, MLK. Here's the deal. I'm going to put, there's another quiz already posted for this coming Wednesday, for the next time I see you guys. I was going to put up a linear regression quiz. I'm not going to now, because I want to finish this the next time around. I got a bunch of fun data sets besides this one to play with. I'm going to put a second, I mentioned I had an idea for another grade quiz. I think I'm going to put a second grade quiz up for next Wednesday. So there's already one extra grade quiz, which is the stuff we finished in class on Monday. I'm going to put a second one up there too. So do as many or as few as you want to do for next Monday. How's that sound? Pretty good? Your project's due too. Oh, that's true. That's true. You're probably. Maybe I'll push the grade quiz back to week 4. Because that way, if you want to do both of them, you don't feel overwhelmed by the fact you have a project and 2 quizzes. Okay, so I will not put a linear regression quiz. I will leave the grade quiz where it is in the project. That's 2 things due on one day, which sucks. But you have a week to do them, so you got plenty of time to knock them all out. Okay, doke? Okay, thank you for reminding me of that. I would have forgotten. Alrighty? Well, she'll turn it off. The same problem. So what? Oh!